This lesson is going to examine the binomial theorem. Binomial theorem is a powerful sort of pattern you can use to expand any binomial expression. For example, the ones we see here. So we're going to try and figure out a pattern here. So x plus y to the power of 0. What does that come out to? Well, anything to the power of 0 is always 1. So that's nice and quick. If we try the next one, x plus y to the 1. Well, that's just itself. So I'm going to write it in a specific way, 1x plus 1y. How will we try x plus y squared? What does that come out to? Well, x plus y squared really means x plus y times x plus y. So if we FOIL this, we'll get the expression 1x squared plus 2xy plus 1y squared. Okay, we've done that before. Let's try the next one, x plus y cubed. What does that mean? It means x plus y times x plus y times x plus y. Well, we know that x plus y times x plus y, we just did that, right? It was x squared plus 2xy plus y squared times the next one. We know the idea of FOIL is I multiply everything in the first bracket by everything in the second. So x squared times x is x cubed. X squared times y is x squared y. And then we do the 2x times x. So 2x squared y plus 2xy squared. And then we do the y squared part. So we'll get xy squared plus y cubed. If I collect that, I end up with 1x cubed plus 3x squared y plus 3xy squared plus 1y cubed. Which, okay, it wasn't hard. It's starting to get a little bit more time consuming here. Oh, we get to this next one. X plus y to the 4. Oh, x plus y times x plus y times x plus y times x plus y. This is getting longer now, right? Now we know that every two of these makes this thing. X squared plus 2xy plus y squared times again itself. Now I can do this. There's nothing wrong with this, but this is starting to get long, as I said. How do I FOIL 3 times 3? Everything in the first bracket by everything in the second. So x squared times x squared. That's x4. So we'll do this one. Then we'll do this one. That give me 2x cubed y. And then this one, xy squared. Then we go to the next piece, right? That thing. So 2x cubed y plus 4x squared y squared plus 2xy squared. I'm going to run out of room here. Move this over a little bit. Okay, and then we go to the next set of brackets. We go to the y squared times each of these three things. So we're going to end up with 9 terms. X squared y squared and 2xy cubed. At the end, y4. Now if I collect those things, I end up with 1x4 plus 4x cubed y plus 6x squared y squared plus 4xy cubed plus 1y4. I think I've seen those numbers before. I think I've seen these numbers when I looked at Pascal's triangle. If I look at Pascal's triangle and I look at the coefficients, the numbers out front of each of my expansions, well, don't these numbers look like those numbers? In the previous row were these numbers. And if I actually stop and think for a second, my exponent tells me what row to go to. Row number 3, row number 2, row number 1, row number 0. Row 4 had these exponents. Row 4. Now, how do I get the letter parts? Well, if you look at the letters, they actually seem to follow a pattern too. The X's start at 4, 3, 2, 1, no X's. And the Y started at 0, then 1, 2, 3, 4. Well, based on that, I could probably guess pretty quickly, if I really wanted to, write out the next row, x plus y to the 5, I could probably do that pretty fast, right? What would that look like? Well, let's see. The next row is 1, 5, 10, 10, 5, 1. So I know I've got 1, x to the 5, y to the 0, plus 5, x to the 4, y to the 1, plus 10, x to the 3, y to the 2. X's are going down, y's are going up, plus 10, x2, y3, plus 5, x1, y4, plus 1, x0, y5. And that would expand that binomial without ever having to do FOIL. Way, way faster, right? Okay, so there's our big idea. We call this the binomial theorem. Here's your writing part. Okay, we can avoid using FOIL as long as we have a binomial, a two-term expression to an exponent. Okay. What we're going to do is we're going to use Pascal's triangle. So we have to take the sum of. We're going to add together each term from Pascal's triangle in row n. N is our exponent. And what's going to happen is we'll take our first term, whatever a happens to be, and our exponent is going to go down over time, times b, the second piece, and the exponent's going to go up over time. You should always have n plus 1 terms. So in the previous one, our exponent was 5. That was the row number. So we actually ended up with 1, 2, 3, 4, 5, 6 terms. So we have checking things. Okay. And again, our exponent should always follow a pattern. They may not always go down and up perfectly the way that one happened. There will be some other instances, but there's always going to be a pattern. Okay? So we're going to try some things here. Okay, so let's try to expand this using the binomial theorem. So a couple of steps that might help you. Number 1, we're going to write out the parts of the problem. What does that mean? Well, it means I need Pascal's triangle to row 4. You know it's row 4 when the second number is 4, okay? So the parts of the problem, I need a 1 times my first term to the power of 4 times the second term to the power of 0. And that's the first part of the problem. Plus 4, first term to the power of 3. Our exponent's going to go down now. Negative x squared to the 1. Let's shrink this out of the way here, okay? Move that up. Plus 6, first exponent, down 1, second exponent, up 1. Plus 4, first exponent, down 1, second exponent, up 1. I run out of room here. Plus 1, first exponent, down 1, second exponent, up 1. There's the parts of our problem. All right, step number 2. We are going to simplify each part. So what can we do there? Well, 1 is 1. We can't do anything with that. But 2x to the power of 4, 2 to the 4 makes 16, and x to the 4 makes x4. Anything to the power of 0 makes 1. Plus 4. We'll apply the 3 here. We'll get 8x cubed and negative x squared. Plus 6, 4x squared. Okay, we're going to square this. Squaring negative 1 makes a positive 1, and x to the power of, well, 2 times 2 makes 4. You've got to apply exponent rules. Plus 4 times 2x, and negative cubed makes a negative, and x to the 6 plus 1, and the power of 0 is 1. And a negative to the power of 4 is a positive. Negative to the power of 4. And x to the power of 8. There's step number 2. Do each part. Number 3, let's multiply the parts together. So what are we going to get? Multiply all this together, we get 16x4. Multiply all this together, minus 32x. We need to add our exponents. Bases are multiplying, add exponents. Okay, multiply next part. 24x6. Next part, minus 8x7. Next part, plus x8. And there's that binomial expanded without ever thinking or talking about the word FOIL. Now, a couple things to check. Our exponent we started with was a 4, so we should have 5 terms. Okay, so n, we can always have n plus 1 terms. We do have 5. Our exponent should follow a pattern. Oh, 4, 5, 6, 7, 8. They do follow a pattern. And one other thing you can actually check, whenever you have a minus sign in your question, which we do in here, your terms should alternate signs, which ours do. Positive, negative, positive, negative, positive. It's one more thing you can check when you're doing the binomial theorem. Okay, let's try another one. Same ideas. So we're going to try and expand this. Oh, we just did that one. This crazy thing. Now, this isn't nice the way it's set up. So we're going to fix it before we ever start. We're going to think about this as being exponents. So x to the half plus, how do I get rid of fractions? I make my exponent negative. Okay, Pascal's triangle. We need the parts and pieces. 1, 1, 1, 2, 1. Third row, right? Here's third row. Third row because n is 3. Okay, so 1. My first piece to the power of the exponent. Second piece to 0. Plus 3. Down 1 with the exponent. Up 1 with the exponent. Plus 3. Down 1 with the exponent. Up 1 with the exponent. Plus 1. Down 1 with the exponent. Up 1 with the exponent. There's my parts and pieces. Step 2, we're going to simplify where we can. So 1 is 1, can't really do anything with that, but I can do a power to a power, and I'll get x to the 3 halves. Power of 0, 1. Okay, power to a power, half of 1, sorry, half of 2 is 1. Power to a power, negative 1, plus 3. Power of 1, multiply that one in, we get x to the negative 2, plus 1 times 1, negative 3. Multiply each piece together now. So we get x to the 3 halves, plus 3. We're going to add our exponents. These two things get added. X to the 1 and negative 1 makes x to the 0. I'm going to put it in there for now, but we will talk about that in a second. Next piece, a half plus negative 2. If I add these together, I get negative 1.5. Okay, and if I do the last one, I get x to the negative 3. The way I've written these exponents makes it kind of hard to tell if I'm following a pattern or not. So I have to talk to myself about either all fractions or all decimals. So if we go to fractions or decimals for a second, I got 1.5, I get x to the 0, and I get, oops, I missed an x in there, x to the negative 1.5, and I got x to the negative 3. Is it following a pattern? Sure it is. It's going down by 1.5 each time. And if I check my exponent, it was a 3 originally. I have 4 terms. Great. And I had a plus sign in my question, so I have all plus signs in my answers. Perfect. And because I had no numbers at all in the entire expression at the beginning, okay, my numbers, my coefficients should actually be totally from Pascal's triangle, which they are. 1, 3, 3, 1. Okay, there's the second one. Last question. What if we want to do parts of it? What if we don't need the entire expression? I don't want to write it all out, okay? But I can do that anyways. So I want to expand and simplify just the first 3 terms of this binomial power. Okay? That would be the 10th row. So hopefully you have your Pascal's triangle handy. We know the first term is always 1, which is kind of nice. My first piece is 5m squared to the 10, and negative 2 and 4 to the 0. My second number in Pascal's triangle is always the row number, so I know it's 10 without even looking at the Pascal's triangle. 5m squared go down 1, 2 and 4 go up 1. And here's where you need your Pascal's triangle. The number from the 10th row, second term is 45. 5m squared go down 1, negative 2 and 4 go up 1. Yeah, parts and pieces. Let's evaluate. Oh, this is going to get messy. 5 to the 10. That's a big number. 9, 7, 6, 5, 6, 2, 5, m to the 20, and times 1, plus 10. 5 to the 9 this time. 195, 3125, m to the 18, and negative 2 and 4, plus 45, and one more big number, 390,625, m16, and here we'll get 4 and 8. Okay, multiply together, 976, 5625, m20, minus, there's a negative sign in there, 390,2500, m18 and 4, and then the last piece, 703,12500, m16 and 8. Now we don't have the entire sequence, so we can't see the whole pattern, but there's enough there to actually see something's going on. Okay, we're alternating signs, which is good because we had a negative sign. Our exponents are following a pattern. The m's seem to be going down by 2 each time, and the n's are going up by 4 each time. So it's enough to give you an idea of the pattern. And that's our binomial theorem for you. We're not going to do too much with it. Some questions you can try, work on. And that would be the end of that lesson.